Hello everyone. Now we will find eigenvectors of the given square matrix. Suppose we have a matrix whose first row is 1, 2 and second row is 2, 1. This is a 2 by 2 matrix, and already we have calculated eigenvalues of this matrix in video number 1. After simplification of characteristic equation, we got lambda is equal to 3 and minus 1. In this video, our purpose is to find eigenvectors associated for lambda equal to 3 and minus 1. So for that, you need to substitute lambda is equal to 3 into a minus lambda I into x is equal to 0. If you put lambda is equal to 3, means you need to subtract 3 from the diagonal elements. 1 minus 3, 2, 2, 1 minus 3 into x. X is a column vector with 2 components because here given matrix is of order 2 by 2. So after simplification, we will get a matrix whose first row is minus 2, 2 and second row is 2 and minus 2. If you apply row transformation here, we get minus 2, 2, 0, 0 into x1, x2 is equal to 0. If you write in terms of equations, we have only one equation here, which is minus x1 plus x2 equal to 0, or you may say x1 is equal to x2 also. So let us choose x1 as 1, so x2 is also 1. Therefore your first eigenvector associated with lambda is equal to 3 is 1, 1. Now we will continue for lambda is equal to minus 1. For lambda equal to minus 1, this equation becomes a plus I into x is equal to 0. Means from diagonal elements you need to add 1. So 2, 2, 2 and 2. Then x1, x2 is equal to 0, 0. Now here again, if you apply the row transformation, we have only one non-zero row, which is 2, 2. If you transfer in terms of equation, that is x1 plus x2 is equal to 0, or you may say x1 is equal to minus x2. Now let us choose here x1 as x2 as suppose x1 as 1. You can take any value, x2 as minus 1. So your second vector is 1 and minus 1. So for lambda is equal to 3, first eigenvector associated with lambda equal to 3 is 1, 1. And second eigenvector associated with lambda is equal to minus 1 is 1 comma minus 1. So this we have done for 2 by 2 matrix. Now we will apply the same logic for 3 by 3 matrix also. Let us solve this example. Same example we have solved in video number 1. We have calculated eigenvalues of this matrix. I'm going to continue from it. So after solving characteristic equation, we get lambda as 1, 2, and 3. Our main focus is to understand how to find eigenvectors for each of the eigenvalues. First, substituting lambda is equal to 1 in the equation a minus lambda I into x is equal to 0. We need to solve this equation and we have to find x. So you need to subtract 1 from diagonal elements. So first row is 1 minus 1 1. Second is 1 1 minus 1. Third is 1 minus 1 and 1 into x1 x2 x3 is equal to 0 0 0. The given matrix is of order 3 by 3, so we'll take 3 components in capital X. Now we know that we can solve this system of linear equations by using Cramer's rule also. If you see the first equation and third equation, they are identical, so we can't take these two equations for Cramer's rule. So you take either first or second, or you can take second or third. So I'm going to take here first and second. I'm going to simplify it. x1 minus x2 plus x3 is equal to 0. And x1 plus x2 minus x3 is equal to 0. Definitely we can use Cramer's rule if eigenvalue is not repeated. So all of you note here, Cramer's rule is a method for solving system of linear equations. Linear equations using determinants. So you have to learn this rule. So x1 divided by, we are going to write the coefficients of x2 and x3 in the form of determinant minus 1, 1, 1 and minus 1. These 4 elements. Then minus, we have to write always along with the second component, minus x2 divided by, now you can write the coefficients of x1 and x3. Similarly, x3 divided by coefficients of x1 and x2. And I'm going to consider all these values are proportional to k. So x1 divided by 1 minus 1 after solving the determinant, x2 divided by minus 1 minus 1, and x3 divided by 1 plus 1 is equal to k. Or you may write x1 upon 0 minus x2 upon minus 2 and x3 upon 2 is equal to k. Or you may write x1 is equal to 0 into k, x2 is equal to 2k, x3 is equal to 2k. So k is here proportionality constant. So we can take any value for k. Suppose k is half, then our first eigenvector associated with lambda is equal to 1 is, if k is half, this will be 0, 1 and 1. So this is first eigenvector associated with lambda is equal to 1. Now I am going to repeat the same procedure for lambda is equal to 2. So in the same example, and now I'm going to consider lambda as 2 for finding eigenvector. So I'm going to highlight what are the changes I'm going to do here. I'm going to take lambda is equal to 2 now. So here lambda is equal to 2. So from diagonal elements you need to subtract 2, and again we need to form the equations, and same use Cramer's rule and you will get a vector. So these are the changes. I'm going to do it now. So let us start. So here instead of lambda is equal to 1, I'm going to write lambda is equal to 2. Okay, let us do the changes. So here lambda is equal to 2 now. Then a minus 2i into x is equal to 0. So you need to subtract 2 from diagonal elements. So you'll get here 0, 0 and 0 diagonally. Now you can form the equation. So 0 into x1 minus x2 then plus x3 is equal to 0, first equation. Second is x1 plus 0x2 0x2 minus x3 is equal to 0. Use the Cramer's rule. So x1 divided by, hide the coefficients of x1. I'm going to change all the values here. Let us see what will be the output of this. Okay. Now x1 divided by, you write the coefficients of x2 and x3, minus 1, 1, 0, minus 1, x2 divided by 0, 1, 1, minus 1, and x3 divided by 0, 1, minus 1 and 0. If you simplify, this will be 1 minus 0, this will be 0 minus 1, and this will be 0 plus 1. So x1 divided by 1, x2 by minus 1, x3 by 1. So here you will get x1 is equal to k, x2 is equal to k, and x3 is also equal to k. K is any arbitrary number. You can take k is equal to 1. So finally, this is your second eigenvector for lambda equal to 2, which is 1, 1 and 1. I hope this procedure is clear. The same procedure now I'm going to apply for lambda equal to 3 also. I hope this procedure is clear to everyone. Let me do the changes for lambda equal to 3 now. I'm going to consider now lambda as 3 here. So there will be a change in these positions. We can use Cramer's rule definitely, because no need to find the rank of the matrix, coefficient matrix. We can use Cramer's rule. We have to take a care while using Cramer's rule that we have to select different equations. Okay, now let us do the changes here. Lambda is equal to now 3. So a minus 3I. So you need to subtract 3 from diagonal elements. 2 minus 3 is minus 1. 2 minus 3 is minus 1. 2 minus 3 is minus 1. Now you can't take again second and third equation. You can take first and second. There is no problem. So minus x1 minus x2 plus x3 is equal to 0. Plus x1 minus x2 minus x3 is equal to 0. Again, Cramer's rule is used here. X1 divided by coefficients of x2 and x3 minus x2 divided by coefficients of x1 and x3 and x3 divided by coefficients of x1 and x2. After simplification, this will be 1 plus 1, this will be 1 minus 1, and this will be 1 plus 1. So x1 divided by 2 minus x2 divided by 0, x3 divided by 2 is equal to k. So x1 is equal to 2k, x2 is equal to 0k, x3 is equal to 2k. Again, you can take k as half. So your third eigenvector associated with lambda is equal to 3 is 1, 0, and 1. Thank you. We have done calculation of eigenvectors associated with distinct eigenvalues, that is lambda is equal to 1, 2, and 3.